morning, students. Welcome back. In our last class, we had discussed about octet rule and duplet rule. Yes or no? So why we need to study this? Because this octet rule and duplet rule is based on the chemical stability of different atoms. Okay. Every atom tends to attain stability by losing or gaining electron. Okay. So this is so because if they do so, if they lose electron or they gain electron, then there is a chemical reaction occurring and there is a formation of new compound and new bond. Actually, I am focusing about bond. Okay. Now there is a formation of bond between two or more than two atoms. Got it or not? Okay, so this bonding process, for the formation of bond, we require electrons. Okay, either some atoms they lose electron, or some atoms they gain electron, or some atoms they share electron, and there is a formation of chemical bond. Okay, so now today we will discuss chemical bonding. Okay, actually bond is nothing but it is a force of attraction between or among the atoms, different atoms. Got it or not? Okay. So bond is just a force of attraction. This bond or this bonding process are of three types. Ionic bond, or you can call it electrovalent bond. Ionic or electrovalent. Next is covalent bond, and last one is coordinate bond. Okay. So the process of formation of ionic bond is called ionic bonding or electrovalent bonding. The process of formation of covalent bond is called covalent bonding, and similarly process of formation of coordinate bond is called coordinate bonding. Yes or no? Let us first discuss about electrovalent or ionic bond. Okay. In a very simple form, you can understand this ionic bond. Ionic bond is formed by transferring of electron or electrons. Okay. So if there is a transfer of electron from one atom to another atom and there is a formation of ion, okay, number one, transferring of electron. After transferring of electron, there is a formation of what? Ions. Remember this. Okay, so in electrovalent compound there are ions. Electrovalent compounds are formed by ions. Okay. Now I'll give you a very simple example. Na. Okay. Atomic number 11. Cl. Atomic number 17. Okay, if you do electronic configuration, then you get 2, 8, 1. Yes or no? Here 2, 8, 7. Now I've already told you every atom tends to have 8 electrons in the outermost shell. Yes or no? To have 8 electrons in the outermost shell, it needs to have 7 more electrons, which is not possible. Which is not the possible case. Yes or no? Yes or no? Yes. So now, if we transfer this one electron here, then outermost will be this second cell. So here second cell we have already have 8 electrons. So this can be done. Okay. So here we have 7 electrons. If we accept this electron here from sodium, then it will become 8. Yes or no? Yes or no? So this is the reason why there is a formation of Na plus. Okay, let me draw this. I draw the outermost shell. Okay, here we have one electron. Chlorine. I draw only the outermost. Here we have 1, 2, 3, 4, 5, 6, 7. Okay, this is one sort of octet. If it donate this electron here, then it will become Na plus. It will become Cl minus. So there plus and minus, there is attraction, and there is a formation of NaCl compound. Okay, NaCl compound is the formation of salt NaCl. Okay, this salt is formed by transferring of electron from sodium to chlorine, one electron. Okay, there is a one, and here are ions present in Na plus and Cl. That is why NaCl. If you make solution out of NaCl, then you get Na plus and Cl minus ion in the solution. That is why ions are present. I already ions. Okay, so electrovalent bond is formed by this way of transferring of electrons. Okay, I'll give you another example. CaO, calcium oxide. Okay, Ca, atomic number 20, oxygen atomic number 8. Okay, 288, 2, this is 2, 6. Two sort of octet. If it 1, 2, oxygen, 1, 2, 3, 4, 5, 6. Both these electrons are transferring from calcium to oxygen. This calcium is 2 plus, oxygen is gaining, that is O2 minus. So there is a formation of CaO like this. Okay, got it? Okay, the thing which you have to remember is this bond, ionic bond or electrovalent bond, is always formed between metals and non-metals. You know this? If you see any kind of metal and non-metal in a compound, then the bonding process is, and the compound is actually electrovalent compound, and the bonding is electrovalent bond or ionic bond. I'll give a simple example. Okay, this is NgCl2. Mg is metal, Cl is non-metal. So you can directly say this NgCl2 is ionic compound or electrovalent compound. But you know, another example, Al2O3. Aluminum is metal, oxygen ko non-metal. Okay, so ionic compound or electrovalent compound. But it or not? Okay. Now, after knowing all this, you can see various examples in your book. Okay, try to understand. Okay, now I'll tell you the properties. Very important properties. Okay. Number 1. All ionic compounds are hard solids. Okay, they are hard solids. Why? Because there is strong attraction between positive and negative charge. If there is circular electron, one always will be positive cation and one always will be negative anion. Listen to this. So there is strong attraction between anion and cation. This attraction is called lattice energy. Okay, because of the lattice energy, they are hard solid, and the form is crystalline. They are crystalline hard solids. Okay, number 1. Number 2, this is very important. They can conduct electricity in aqueous or molten state. Aqueous solution or molten state. This is very important line. I'll explain. Number 3. When solid, they do not conduct electricity. Okay, these two lines are very important. Okay, when you have dry and solid NaCl, this NaCl cannot conduct electricity. Solid. Okay, pure solid, dry solid. Okay, and if this is solution, NaCl means solution, aqueous solution. If you mix this NaCl in water, then it can conduct electricity. Okay, why? Because in solid state, this Na and Cl are attracted very strongly. Okay, it is difficult to break this bond. Okay, to separate Na plus and Cl minus ion. In solid state, this Na plus and Cl, these ions are not separated because of strong lattice energy, strong bond, strong attraction between Na and Cl. Okay, when you dissolve this in water and if you make a solution, then there is the formation of Na plus and Cl minus easily. Okay, then it can conduct, because in solution state ions are responsible for the conduction of electricity. So here formation of ions, so conduction of electricity. Here no formation of ion, no conduction of electricity. Correct? So all ionic compounds can conduct electricity only in aqueous or molten state, not in solid state. Got it or not? Okay. So now, after knowing all this, these are the most important properties. Let us move on to covalent bonding. Okay, this bonding process is actually electron sharing process. Okay, and the bond is formed by sharing of electron or electrons. Sharing of electrons. Very simple example. I'll give you example of hydrogen gas. F, we have one electron. Another H, we have one electron. Yes or no? So to attain duplicate configurations, these are smallest elements. Okay, so smallest element tends to have two electrons in the outermost shell to attain stability. So if it donates one electron, then it will have two electrons, but here it does not. It will not have any electronless. Okay, so which is not the case actually. So now it needs to have two. It also needs to have two. If they share electron like this, then let us see what kind of situation arises. This is the situation. These two dot are electrons. Okay. Now for this hydrogen also two electrons. For this hydrogen also two electrons. Yes or no? So both of these two hydrogens are having two electrons. So this is the case. Here is a sharing occurring. Yes or no? So there is a formation of H. Double electron, single bond. Two electron, one bond. Remember. Now this is H2 gas. Is formed like this. Okay. Similarly, let us do for oxygen gas. Oxygen. 1, 2, 3, 4, 5, 6. Outermost 6. 1, 2, 3, 4, 5, 6. Yes or no? Oxygen 8, so 2, 6. Outermost 6. Sharing of these 2 electrons. So oxygen shared electrons like this. 1, 2, 3, 4. Unshared electrons as it is. Yes or no? If you count electrons for this 1, 2, 3, 4, 5, 6, 7, 8. For this 1, 2, 3, 4, 5, 6, 7, 8. Yes or no? So oxygen, how many bonds? These 2 electrons. 1 bond, these 2 electrons. Another bond. So O double bond. O, that is O2. Got it or not? Okay. Let us do another example. That is nitrogen gas. N. What is the atomic number of nitrogen? 7. Yes or no? 2, 5. 1. Okay. 1, 2, 1, 5. Nitrogen. 1, 2, 3, 4, 5. 3, 3 sharing like this. So nitrogen. Another nitrogen sharing 1, 2, 3, 6. Unshared as it is. Unshared as it is. So nitrogen 1 bond, first, second, third, 3 bonds. So N. This is N2 gases formed like this. Sharing of electrons. Okay. Okay. We have various examples. We'll do another examples in our next class. Okay. So this was for today. Try to understand this, and we'll have more and more example in our next class. Thank you very much for today.